All right, guys, here's the last section of chapter 2, just those last 3 questions. So, number 16, we've got this graph and it's very, very simple. X-intercept and Y-intercept, okay? My x-intercept is at -3. Now, here's the thing. You got to know your coordinates. It is -3, 0. Remember, coordinates always go x value, y value. The reason I make the point of this is because when you start looking at your answer choices, H and J are out because they have -4, which isn't the x-intercept. But notice that they know you're going to make those mistakes on the coordinates, so be careful about that. My y-intercept is down here at -4, so it's an x of 0 and a y value of -4. This is an easy question, but y'all have a tendency to mix up, especially when there's a 0 involved. Y'all have a tendency to mix those up, so please be careful. Number 17, Juanita has this function, graph the line. Okay, remember mx plus b. It's kind of a big deal. It keeps popping up everywhere. So I'm going to begin on -1, and then I'm going to rise to run 1. So up 2 over 1, up 2 over 1. I can continue that pattern all the way through. Okay, so that's our first question, is just graphing that function. It is an equation, so I'm going to go ahead and connect it, and draw my arrows. How does this compare to the parent function? Well, if you don't remember what the parent function looks like, let's go in and do a new graph. I'm going to enter Juanita's function, 2x minus 1, and then the parent function is just y equals x. On a linear function, it's the most basic one. So how is Juanita's different than that? Well, the y-intercept is shifted down 1 unit, so it's shifted down. And you always want to kind of look at 2 things. What is the y-intercept doing, and then what is the steepness doing? So the red is my original, the blue is Juanita's. Well, Juanita's is steeper. If I imagine climbing that mountain, it got steeper. So it's shifted down 1 unit, and it is steeper. The second part says, what would happen to the graph if the value of the y-intercept were increased by 4 units? So if I took her y-intercept and I bumped it up 1, 2, 3, 4, well, now my y-intercept is at 3, positive 3. It's not saying it goes up to 4, it's saying it increases by 4. So her function would now be, her slope doesn't change, 2x, but now it's plus 3 instead of minus 1. Okay, pretty simple question. Number 18 is taking this to a more real-world scenario. So it says water in a barrel's leaking out. Here's our function. So I'm starting at 48, and I'm going down 3 for every 1, 3 inches per day. Now, here's what's tricky about graphing this, is I'm not counting by 1 day down here, okay? I'm not counting by 1 days on the side either. I'm counting by 3s and 6s, and so I've got to kind of figure out, okay, if I'm dropping 3 inches every 1 day, well, let's figure out how far we're dropping in 6 days. That way I can skip to that. So if I want to know how far we're going in 6 days, this is simple proportion, right? I multiplied it by 6, so I'm going to multiply this one by 6. We're actually losing 18 inches every 6 days. So 48 minus 18 drops to 30 for 6 days. 30 minus 18 is 12, another 6 days. I can't go down the next one because I'm down into the negatives. I mean, I guess I could, and then I'd be over here somewhere. It says interpret the x-intercept and y-intercept. Well, let's start with the y-intercept first because I just think it's easier. The y-intercept is 48. 48 what? Well, it's 48 inches of water level. Well, what's the x value for that? Well, I have a number of days of 0. So it's 48 inches at 0 days, which is also known as my initial or starting value. Okay, so I started with 48 inches. My x-intercept is not a nice clean number, which kind of stinks. Okay, I know it's going to hit somewhere around in here. If I want to know exactly when, well, let's do this. let's give me a new calculator or a new graph page. Negative 3x plus 48. I can't see anything. Why can't I see anything? Well, because look at my graph. It goes up to 48. And I know it's going to cross somewhere over here between like 12, 15, 18 area. My graph only goes out to 10. So let's go ahead and do menu, zoom, and I'm going to see if this will work. I'm going to try zoom fit. Sometimes zoom fit is good because it just automatically goes to what your data is. It kind of worked. So let me do this. I'm going to grab this and just kind of slide it where I want it. To do that, I'm just going somewhere on the graph, holding down my center button until it turns into the little fist, and then I can just slide and move whatever I need to, okay? And then to get out of it, you can either center click or you can press escape or whatever. All right, I'm gonna do menu, trace, and let's just graph trace. And so now I can kind of move along my graph. Let's go down to that x-intercept. Could just hold it down instead of clicking forever and driving myself nuts. And notice it tells you, hey, that's the 0. That's where I'm hitting the x-axis. X-intercepts and zeros are the same thing. So at 16, 0 is where we're actually hitting right there. So what's significant about that? Well, 16 what? 0 what? It's 16 is the number of days, and 0 is the water level. Oh, well that means my water ran out. Okay, you've always got to, if you go and look, oh well at 16 days I had no water, it kind of tells you what it is if you actually put labels on your coordinates. How would the graph change if the rate at which the water was leaking out were cut in half? So instead of losing 3 inches per day, now I'm losing 1.5 inches per day. Well, let's think about it. So instead of going down 3 over 1, I'm only going down 1.5 over 1, and so forth. So you kind of have to visualize, well, my graph is just going to get steeper. Any guesses on when it might end up crossing down here? Well, it crossed here at 16. If I cut that in half, if I'm going twice as slow, it's going to take twice as many days to cross. So it's going to cross over here at 32. So at 3 inches per day going to 1.5 inches per day, my graph is less steep. And the x-axis, or sorry, the x-intercept is now 32 days because it takes it twice as long to leak out. Okay? All right, that's it for chapter 2.